US Physics Olympiad 2010 year, USAPHO Semifinal. Problem A4. The energy radiated by the Sun is generated primarily by the fusion of hydrogen into helium-4. In stars the size of the Sun, the primary mechanism by which fusion takes place is the proton-proton chain. The chain begins with the following reactions. First reaction: two protons go into element X1, positron E+, and element X2. The second reaction is proton plus element X1 go into element X3 plus gamma ray. The amounts listed in parentheses are the total kinetic energy carried by products including gamma rays. P is a proton, E plus is a positron, gamma is a gamma ray, and the X1, X2, and the X3 are particles for you to identify. The density of electrons in the Sun's core is sufficient that the positron is annihilated almost immediately, releasing the energy X. During this annihilation reaction, electron plus positron go into two gamma rays. Subsequently, two major processes occur simultaneously. The PP1 branch is the single reaction. Two elements X3 go into helium-4 plus two elements X4, which releases an energy Y. The PP2 branch consists of three reactions. First reaction is element X3 plus helium-4 go into element X plus gamma ray. Next reaction, element X5 plus electron go into element X6 plus element X7. And last reaction is element 6 plus element 4 go into two helium-4 particles, where Z is the energy released in step 6. So, questions. Question A. Identify X1 through X7. X2 and X7 are neutral particles of negligible mass. It is useful to know that the first few elements in order of atomic numbers are hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. Question B. The mass of the electron is 0.51 megaelectron-volt per c square. The mass of the proton is 938.27 megaelectron-volt per c square. And the mass of the helium-4 nucleus is 3727.38 megaelectron-volt per c square. Find the energy released during the production of one helium-4 nucleus, including the kinetic energy of all products and all energy carried by gamma rays. Question C. Find the unknown energy X and Y above. Question D. Step 6 does not proceed as follows because there is insufficient energy. X5 to X6 plus positron plus X7. What constraint does this fact place on Z? And the question E. in which of the reaction steps is the energy carried by any given product the same every time the step occurs. Assume that the kinetic energy carried in by the reactants in each step is negligible, and that the products are in the ground state.